Hello everyone, welcome to the next video. In this video, we are going to discuss about the general method for the construction of ellipse. Take down the question. Trace the curve when the distance of the focus from the directrix is 550 mm with eccentricity as 2 by 3. With this data, we will construct the ellipse by using AutoCAD. How it will be? We will look it up. Once we enter into the AutoCAD, it is mandatory to check the initial setting, that is units, limits, dimension style, point style. Please check all those things whenever you enter into the AutoCAD. Okay. Now, eccentricity E is equal to 2 by 3 is given to you. The distance from directrix to focus is given as 50 mm. So make sure that ortho is on. I am drawing a vertical line. At the midpoint, I am drawing a 50 line. 50 line, that is distance from directrix to focus. So mark that by using text. This is my directrix D. Say this one is P point. This is V. No, this is whatever focus F1. What we have to do? We have to divide this PF line into 5 equal parts. Why 5 equal parts only? E is equal to 2 by 3. Numerator plus denominator. 2 plus 3 gives the 5. If the eccentricity is given as 5 by 8, we might have divided this PF1 into 13 parts. Okay. Now we divide this into 5 parts. Divide. Select the object. Object is selected. 5 parts. So now the question is where we should keep the vertex. Vertex. So I am repeating this text. Start point, text height. This is the third point, V1. This is the conventional procedure adopted in engineering graphics, drawing sheets, right? So how much VF1? Please measure that one. How much that value is? It's 20. So draw a vertical line from here of 20. Okay, such that VF1 is equal to this line. Now join, make sure that ortho is off. Join this P to this apex point. To this apex point carefully. Now delete this PF1. Why we should delete that one? We'll later on we'll discuss. Oh, fifth point is not there now. Okay. With focus as center, draw a line. To find the second vertex, we adopt this method. From the focus, draw a line 45 degrees. 45 degrees with respect to the horizontal by using command @ some give the arbitrary length at less 500 less than 45. Somewhere it enter into the infinite space, right? So the main agenda is we should project this line onto this 45 degrees line. Okay, how we are able to do that one? Use this method. It will be very easy. Use the command fillet. Fillet. When it is asking the fillet, it gives throws these options: undo, polyline. Go to radius. By default, radius is 0. Enter. Select the object. This is my first object, and this is my second object. Automatically, both these lines will merge at some point. Okay. The points where both these lines merge, draw a vertical line. Make sure that ortho is on. At the same time, delete this PF1 line. Join V1 onto this line, and this line becomes the vertex V2. To identify the second vertex of the ellipse, we are applying this method. What is this method? Draw a line which makes an angle 45 degrees with respect to the horizontal from focus, and extend this line apex point to the up to last point. Okay, this is the vertex V2. Text. It is my vertex V2. Okay. Later on, divide this V1 and V2 into equal and or unequal parts. Divide by using the command divide. Select the objects. Say for suppose I am using the command segments 12. Okay. These are the points. Okay. Number those. Text. While doing so, make sure that you should not confuse. Otherwise, entire procedure will go wrong. Even though it is slow process, do it very, very carefully. Upon practice, you will expertise in this. 8, 9, 10, 11, and this is my last point 12 or view. Okay. From this one, use the command copy from the modify toolbar. From here to 11th point, 11th point to 10th point, 10th point to 9th point. You know how to copy the object. 6, 5, 4, 3, this is my last, 2, 1. Okay. After drawing all those things, trim the extra other portions. Outer portions you trim carefully. Okay. Trim this one also. Okay. Now, number this. Number this by using the text command. Text start point 0. This one has 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. On the inclined line, whatever the lines we are mentioning with dashes. Okay. Now, use the command. What we will do in the conventional drawing sheets, we'll mark 1 dash with the compass, which measure the 1 dash radius as compass, and with focus as center, we'll cut the first line. But in the AutoCAD, we will use the command circle. Draw the circle with 1 dash as radius, and move this circle to focus point. This is my focus point. Focus point and second point are same. Okay. So the point where it intersects the first line, that is my first locus point. Mark it. For my convenience, I am changing to red color. Okay. They are drawn. Delete this one. Okay. Similarly, from circle to 2 dash as radius and focus as center, draw an arc on the second line that exactly intersects at the second point. Single point. Okay. Next, delete this circle. For cycloid, epicycloid, hypocycloid, the radius is constant. Rolling circle radius is constant. But in ellipse, the radius vary. That's the only difference. The procedure remains the same. 3 dash as radius and focus as center. Cut the third line. Similarly, draw circle. 4 dash as radius. Focus as center. Cut the fourth line. Focus as center means just we will move the center to the focus. Mark these points to red color so that for better indication of these are the locus points. Delete. Next. With 5 dash as radius. Focus as center. Draw the point. Mark the point on fifth line. Convert the color. Then delete this one. Circle with 6 dash as radius. Focus as center. Cut the sixth line. Mark it by using the point, single point. That one delete. Not to red color. Then again use this command circle with 7 dash as radius. Move the circle to focus point. It need lot of concentration. Small mistake, it will change the shape of the curve. Okay, so draw it very carefully. Even though process is slow, the methodology remains the same. 8 added radius. Focus as center. Cut the eighth line. Draw point, single point. Okay. Then circle 9 dash as radius. Focus as center. Cut the ninth line. Okay. 10 dash as radius. Mark the point on the 10th line. Similarly, delete this one. 11 dash as radius. What happened? Some mistake. 11 dash as radius. Move to the focus point. Draw point, single point. Okay. Mark these points and convert to red color. With 12 as radius, that is the 12 data sheet will be the apex point, right? Last end point. So mark that point carefully by using single point, and change that color to red to indicate these are the locus. After drawing all these locus points, with respect to horizontal, make a mirror. Select that all these points carefully, one after another. Modify, mirror. This is my first mirror line and this is my second mirror point. Enter. Okay, these are the locus points. These are the various locus points. Now, number these. Before numbering, join the curve by using spline. You're drawing. Never start the curve from this V1 point. You can start from anywhere else. Why? Because the curve at the ending point will be somewhat tedious. Join carefully each and every point. Oh, if something mistake is there, shortcut is Control Z, that is undo. Join these points very carefully. Again and again I am saying. This is my point. Then how to end this curve? 3 times enter. 1, 2, 3. Yes. This is my curve. This is the ellipse. So select that curve, change the color, apply the line thickness, make sure that line weight is on. Okay. On the periphery, red points are the locus points. Mark points on the curve by using the command text. This is my start point. 3, 0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, P12, P13, P14, P15, P16, P17, P18, P19, P20, P21, P22, P23, P24, Last point is the P1 again. Okay. What is the name of the curve? Ellipse. Ellipse by general method or eccentricity method. Eccentricity method means we are using eccentricity, you are drawing the sketches. In this way, based on the eccentricity is equal to 2 by 3, we will apply this procedure. If it is a parabola, the VF and what we have, it will be at the midpoint, not on the third position. Whereas with the hyperbola, the E is equal to 3 by 2 now. So from the direct to the second position, you will place the vertex. So in this way, we are going to address this conical curves by using general method. Next video, we'll discuss about the other engineering curves. Thank you.